Hi everyone. Okay, so today I'm just going to go through the slides for presentation on descriptive statistics. Okay, which is for this lecture. Okay, so there are quite a number of slides in this presentation, but I won't be going through each and every single slide. Okay, some of it just some examples which you can actually go through and try it on your own. Right, let me highlight the important things and proceed to the following slides. Yeah. So, okay, the overview. Okay, descriptive statistic is usually used by researchers for reporting on any populations or samples. Okay, so if you can recall, population is the actual size of the subject. Okay, which is the, for example, if you are doing a study on, for example, University Malaya students. So, if you are taking the subjects from everybody, every student in University Malaya, that means it's a population. But if you are going to take sub, that means you're taking a group of people to represent the whole numbers of students in University Malaya, then that is now called a sample. Okay, so whatever report or anything that you're going to write to represent on populations and samples is called descriptive statistics. Okay, so basically how you do it is by summarizing some information, and descriptive statistics also speeds up and simplify comprehensive or group characteristics. That means when you are studying some kind of trend or pattern or behavior in that particular population, okay, this kind of descriptive statistic that you're going to see after this helps you to somewhat conclude or summarize on what is actually happening or what you actually can observe in that particular group that you are studying. So as what I explained just now, population is basically is everything, but if you take the smaller part of the population, that will be called a sample. And I believe for your group project, most of you are doing sample because usually we won't have that capacity or the finance in terms of doing a research where we want to include all the whole population. All right, so that is why we ensure that when you're doing sampling, that sampling has to be a very reliable one. Okay, so descriptive statistics, for example, okay, here we have an illustration. Okay, for example, there's two class A and class B. All right, so there is one question here. Okay, which group is smarter? Okay, each group have 13 students. Okay, and this is the score, IQ score that they have got, right? So if you can see, there are 13 in each of these classes. So each individual may be different. If you try to understand a group by remembering the quality of each member, you become overwhelmed and fail to understand the group. All right, like you cannot be studying each and every individual in the group, okay, or even remember actually what is their IQ level, right? So one way, I mean, this is a simplified version, sorry. Okay, so you want to summarize what is their IQ level, all right, if you want to call that as smart, right? Okay, so we have this raw data. So what can we do with this data in order to kind of give some kind of score to describe the smartness of the classes? Okay, so here you can see what we did is average, right? Average is one way of describing a behavior or a pattern that you observe in the class. So in this case, which group is smarter? So by using average, okay, we can get a score of 110.54 for the class A and 110.23 for class B. So they are roughly the same. So with the summary descriptive statistic, it is much easier to answer a question. So in this case, using average, you can say that both classes are smart, equally smart, right? Of course, these are the basic things that you need to know. As you proceed further in the next lectures, we will look at other statistical tools that are very useful in concluding or observing and making summaries, okay, to understand the behavior of a study that you are doing. Okay, some of other types of descriptive statistics is using tables and graph, right? You organize data and you display it you present it in a table or graph form. Summarizing data, we have central tendency, right? Average is basically central tendency, but there's many ways of actually you can compute the central tendency. Okay, and also variation, all right? You can also look at variation, which we look after this. Okay, here are some samples of the tables. Okay, you can organize tables in a form of frequency distribution. Basically, is how it's like individual numbers, right? In terms of the frequency, or you can say the counts, right? It's the counts. Okay, or you have relative frequency distribution. You basically is a compilation of each frequency, right? Graphs, you can have bar charts, stem and leaf plot, frequency, polygon. There are many more. Actually, there are many more. What we show here is just some samples. Okay, for example, there's a assume there's an SPSS output here. All right. So these are the scores. If you can see on your left here, assume these are the scores. Okay, and for example, the frequency of this particular score in that particular class, just say maybe only it appears once. 87 1, 89 1, 93 appears twice. Okay, the frequency is twice or appears twice. What else appears twice? 131 appears twice. So in total, there are 24. Basically, there are 24 observations here. Okay, and then these are percentage. Okay, you calculate based on the total, right? And this is the cumulative percentage as you add on to the next until it becomes 100. All right, the percentage. So these are some examples of data that you can produce in your SPSS. So this was the frequency distribution, right? 112. This is similar to what you saw here. I'm just picking it out for you to see. Okay, this is the frequency. Okay, so total is 24. And relative frequency distribution is when you have this thing here, all right? When you have the cumulative percentage included here. So you accumulate for the total 100%. Okay, group relative frequency distribution is similar, right? You also calculate the frequency of each, but now you actually categorize or group certain, for example, in this case, we are grouping the IQ from 80 to 89. That means anything that falls between 80 to 89, you count in a group. For example, 80 to 89, if you see this, 80 to 89, there are 1, 2, 3. So now you're grouping them, okay? And then, for example, 90 to 99, is 93, so it falls 93, 96, 97, 98. So all these will fall under the second group, which they are total 5. Okay, so different ways of you actually tabling the same data. All right, it all depends on the needs. All right, whether you need to group or you don't want to group. All right, sometimes I can give you some examples, just say age, right? Sometimes you can ask age, like some students were asking me today, how do we group age? For example, can I just group 18 to 25 and then 26 to 30, 31 to 35? I mean, if when you're doing some kind of groupings like this, usually you need some kind of a reason why you want to group them that way. For example, later on, if you need to some kind of do some summarization, okay, why this particular group have certain behavior or certain relationship that you found out. So at least the grouping has some kind of justification why you group them like that. For example, maybe you can say that below 20 is one group, okay? Or you can say, just say 0 to 7 one group, 8 to 12 another group, 13 to 17 another group, 18 to 25 another group. Okay, if you look at the group, the way I grouped it is I go by their academic background. That means they are either in preschool or below. Second group was primary, right? Third group was secondary. And fourth group was in tertiary education. So when we are doing some kind of conclusion later on, just say you some relationship with another factor or what, at least you can say, oh, the group from between 18 to 25 had showed some behavior or some kind of observation. So you can say that maybe because they have certain similar characteristics, which is all of them are in tertiary education, right? So there is a way of you grouping. Sometimes, I mean, you don't group for the sake of grouping, you group maybe later on it will help you to some kind of do some conclusion or summarization that might be meaningful or helpful to you. Okay, okay, just here I'm just showing some of bar charts, okay, some diagrams like histograms. So these things I know some of you already have done during your matrix or form 6, right? So these are the similar things. We have bar charts, histogram, which you plot based on frequency, right? So this is another sample of bar graph. Okay, so I did mention on summarizing data, there are two things here that we are going to cover, which is central tendency and variation. Okay. So basically central tendency is about middle value. Okay. What is the middle value? So we are going to look at mean, median, mode. Okay. But please understand that there is many kinds of central tendency. Okay. Even mean itself, you can actually look at many types, you know. I don't know if you have heard of harmonic mean, right? Geometric mean, right? These are the various different kinds of mean or central tendency, and the purpose also is different depending on the study that the person is doing, right? But here I will just mention that what we are going to look through is mean, median, and mode. Okay, in general. And then we are looking at some variations which are like range, interquartile range, variance, and standard deviation. Okay, mean is basically just our average. Okay, you sum all the counts of data and then divide by the total number of data or observation that you have. Okay, so I won't be going through again through this. For example, let's use the same example like just now, right? We have the 13 data in each of this class. So basically, for example, you want to find the average or mean for class A. You sum up all the values in class A, which are the 13 values, and we get here 1437 divided by 13, right? And then we got 110.54. Same thing you do with class B, you will get 110.23. Okay, and then some characteristics of mean. Okay, some bad things about mean is mean can be badly affected by outliers. So what is outlier, right? Outlier is a value that might be far from what is the usual value that we get for that particular observation, right? For example, just say in this class, just say in our class, uh, we might have an out. Okay, just say one student, particular student is a veteran. Just say, okay, all of you mostly will be between 18 and 25. Okay, mostly will be between 18, 23, 25, like that. If we have one student, particularly maybe just say a veteran, okay, or maybe say the student is about 40 years old, okay, who is also in your class, so that is a outlier. That means if you're doing a study and then the person is collecting data using your class students, right? And then everyone's age will be between that range, you know, between 18 to 25, but you might have one outlier, which is a person who is maybe 40 and above, right? So it might not necessarily impact negatively or positively. It depends, right? Look at what you're looking at, right? So sometimes this kind of data might be better to be not included because they do not represent the actual or the common behavior of that particular group. All right, so that is why we try to, whenever we get a data, if first thing to do is cleaning, and you try to remove the outlier data that you see in your data. All right, this is to avoid any kind of misinterpretation or that can cause your results to not be that accurate, because some are just by maybe by chance that that particular data is different, right? So to avoid any kind of effect on the results, we usually try to remove or filter out these data to ensure that we get a more reliable outcome that represents the particular group or study. Okay, all right. So median is another central tendency. It's basically simple. To put it simple, it is the 50th percentile. Okay, that means what you do is usually you rank them from small to the largest value. Okay, so you rank from the smallest to the largest value, and then if the total number is an odd number, it's easy. You just take the middle number, right? But if it is a odd, if it's an even number, then you have to take the center two numbers and you find the average. Okay, for example, here 13 students, there are 13 IQ scores, so it's an 13 is an odd number, so it's easy. You just take the middle number here after ordering it from small to large, right? So 109 is the median, but assume you have only 12. Just say assume I remove this 89 here, so I only have 12, so I cannot take any because I don't have a middle value, right? So what I have to take is I have to take the middle two values and then sum it, and I find the average, right? So in this case, if I don't have that particular data on top, then now my average, new average is, new median will be 109.5. Okay, median is much less affected by outliers. Okay, why do you think so? First, you must understand, if at all, just say we are ranking here, right, these numbers, we have an outlier value which is about, maybe just say 60, or, okay, this is not a very good data. Maybe just say this is the, we have a data of age, right? Okay, we have, as I told you, most of you will be 18, 19, 20, 21, right? And then you have one data which is, the student is 60 years old or 40 years old, okay? But when you use median, what you will do is you basically will order them, right? You will order them from smallest to the largest. So in this case, the other values is, does not affect your median value. I mean your central tendency value. What affects is the center 2 values. So in this case, if your center 2 values are, outside the outlier values, that is quite safe. That means you will get a roughly an average value compared to the mean, because the mean takes into account all the values, but median doesn't. It only takes into account the middle values. So if you have an outlier value, usually they will be either too high or too low, right? So you can how to say, omit this, or you can ignore these values, because median does not take into account the highest and the lowest. All right. Okay, so that is about median. Okay, mode. Mode is basically about how frequent, the highest frequency. So you order them again. Okay, you order them, and then if any repetitive values you put together, right? And which one has the highest mode is the one that appears the most frequent. So in this example, 109 appears 3 times. So the mode is 109. But please understand that you can have more than one mode. True? Yes, because for example, just say there's another student got 93. So now you will have 393s. If 393s, that means the mode is 93 and also 109. Okay, so I don't really believe, if you ask my opinion, a mode might not be a very good central tendency value compared to mean and median. But if you look now, people still use mean a lot compared to even median, right? Because the easiest thing what you will do is, when you have a data, you will clean it up to remove all the outliers, and then you use the mean central tendency. It solves the problem, right? Okay, so just checking here. Okay, we have done mean, median, and mode. So after this, I will do the range, interquartile range, variance, and standard deviation. Okay, now let me go into variation, which is one of the variation will be range. Okay, so it basically shows the spread of the distance between the lowest and the highest value, right? That is range, right? So you will always have what is the minimum and what is the maximum, and you see the difference. Okay, so in this case, what is the range in this for class A? The highest here value will be 140 and the lowest is 89. So the range for class A is 51. For class B, the highest is 162, the lowest is 80. So the class B range will be 82, because highest 162 minus lowest 80 is 82. So quartile is basically is division that breaks a series of values into 4 different parts. Okay, usually is 1/4, half, quarter, half, 3/4, and full. Right? That means 25th percentile, 50th percentile, 75th percentile, and also the 100, which is full, right? So it's basically, you also can say it's by percentage, right? 25%, 50%, as you after you order the values. All right, so let's see interquartile, right? Interquartile is basically is right, I think I'll be mentioning that. Okay, never mind. Let me go into variance first. Okay, so what is variance? Okay, now basically we seldom use variance per se. Usually we use standard deviation, right? But anyway, in order for you to find out standard deviation, you need to calculate variance in the first place. All right. So basically, what is variance? Okay. To put it simply this way, if you have a collection of data, just say, okay, I'm collecting a data of student CGPA in a class. Okay. So I can calculate what is the average of the CGPA of most of of the students in the class, right? But if I want to understand how is this the spread of this value, or you can say what is the measurement of dispersion? Okay, that means how are these values, each individual values in the ones that I collected, are actually distributed. Okay, for just say in my class there are 30 students, the CGPA average is 3.0. Okay, so variance basically tells us how all the other students, or all the students in that group, um, not to say differ, or how far are they in terms of CGPA from the mean value. Okay, that means I have now the mean, which is 3.0, right, for the 30 students in the class. But I can also find how far is each of these students, the 30 students in the class, from the mean value. So what does that tell you actually? Right? It tells you most of your data are below, you can say, is it close to the mean, or are they dispersed far from the mean, right? So you might need this kind of observation to make certain kind of conclusion, because if just say if your variance is far or quite big, what does that tell you? Right, that tells you that most of the data that you collected, I mean most of the CGPAs in that group are actually very far from your mean. That means the CGPA mean was 3.0, but if your variance is very high, most probably majority of the students are seated, I mean their CGPA is very far from 3. Maybe they are 2.5, 2.0, or the extremes, or there will be 3.7, 3.8, 3.9, and they are not close together to the mean, right? But on the other hand, if my variance is small, that means most of the CGPAs of the students in the class are revolving around 3.0. So what kind of conclusion I can make? Let me just say I have two classes, right? Both classes, the average is 3.0. Okay, class A, the variance is high. Class B, the variance is low, right? Then what I can deduce from there is class A, if the variance is high, CGPA 3.0 is the mean, but the variance is high, that means the performance of the students in the class really vary between students. Okay, some are very good, some are not that good in terms of performance academically. But just in class B, the CGPA average is also 3.0, right? But the variance is very low. That means the variance is small. Okay, this gives an idea that most of the students in that class B is actually performing very similarly, right, in terms of academic performance. Okay, as maybe if I'm doing some kind of assessment on the lecturer or the teacher who's teaching that particular class, I would say that the class B is doing well, or the lecturer or the teacher of class B is doing well, because all the students are equally like kind of obtain the knowledge, or they manage to secure good results roughly about 3.0, compared to the other class, which was very different, very different, like some are 3.8, some are very low, so we don't know what is the reason that causing. But that kind of results as well can let us know or alert us, okay, now that is interesting, why the class A have a different kind of variance compared to class B. So maybe there's something to explore there that we need to do to understand, okay, so there is some kind of variance is happening, most of the students are scoring differently, right? They have the same lecturer, the same student, the same resources, what is different? Okay, so these are the things why you need to know variance and standard deviation. Okay, please understand why I'm trying to explain this is because most of us, what we do is, I'm not sure about how are you, but in school, sometimes what we do, okay, we learn, right? We learn something, but do we know how we want to apply it, right? So in case you were not aware of how you can actually apply variance and standard deviation, that is why I'm explaining, right? So that you know, we do learn about standard deviation and variance is because we want to understand the behavior of the data that you have collected. Okay, that is the purpose of looking at standard deviation and variance, right? It is not just for the sake of computing that score, and what is more important is for you to understand what does that value tells you. Okay, so I hope you get some idea on what I mean by variance and standard deviation, because in terms of computation, I think you'll be able to compute, but what is more important is how do you deduce, how do you interpret the results. Okay. All right, so there is some examples here. Please go through, because I'm sure there's I'm already given the examples there. You can see how to compute it. Okay. Again, what is important is what does that mean, right? What does these values mean? Okay. All right. So yeah, these are the same formula. Okay, the formula for variance is basically this, right? Sum of squares, right? Which is y bar is the average value, right? Average value. So every single value or data that you observe should be subtracted, should subtract the mean, okay, and you square them to make sure that you don't have a negative value, right? Because sometimes some data is smaller than the average value, so you tend to get an negative value, right? So to avoid this, we square and then you sum up all these values, okay, you get the variance. For example, like this, right? You square minus square, this is for the class A. Okay, so you get the square sum of square as 2825.39. Okay, so what do you do with variance? Does it mean anything to you? Okay, but anyway, for variance, the last step is you have to divide by the the number of values. So if you are using a population, then you divide by total number of observation. Okay, but if you are dealing with a sample, then you have to divide by total number of observation divide by 1, right? So in the case like just now, 13 students in that class, so it's a sample, right? It's not a population. So your variance should the value, the sum of square just now, you have to divide by n minus 1, which is 2825.35 divided by 12. Okay, the question now is, so what do I do with this value of 235.45? Is it high? Is it low? So what does that mean, right? But that is why I say we don't really use variance most of the time. We go for standard deviation. So that standard deviation is in a form where we can actually make some interpretation. Okay. So basically standard deviation, you square root, right? You square root the variance, you get standard deviation. So now the standard deviation is 15.34, right? So just now it was 234.45 is was the variance. So now when you square root it, you got 15.34. So can you do anything with 15.34 now compared to the variance value? Yes, right? So now you can say the average of person's deviation from the mean IQ of 11054 is 15.34. That means most of the scores in that class A is plus minus 15.34. Okay, that means most of the values, majority of the values in class A, the scores will be plus minus 15.34. What I mean plus minus is 110.54 minus 15.34 or 110.54 plus 15.34. So it will be in this range, right? So it helps you to understand the range where the data is in. So basically you are understanding how it is dispersed, right? Okay, so that's all about standard deviation. Okay, some of the things I think the others you can read about and try some of the exercises here, okay, which are given in the example. Okay, I have explained about variance and standard deviation. Okay, some of the examples please try on your. Now let me move on because there are some other issues which I want to highlight later on at the end of the slides. Okay, so percentiles is basically you're dividing a set of data into 100, right? Into 100 groups, right? So each data basically is 1%. right? So is so if the way of finding what percentile is that particular data is basically percentile value x. If x is the value that you want to find the percentile for, find how many of other values below the value x, and then divide by total number of values times 100. Okay, for example, here there are 40 chips of cookies. Find the percentile of a cookie with 23 chips. Okay, with 23 chips. So we can see we order it first, right, from smallest to the largest number, and then we actually have to see 23. Where is it? Okay, it is here. Okay, so how many values are lower than 23? So in this case, 1 2 3 4 5 6 7 8 9 10, right? There are 10 values which are lesser than 23. So it's 10 over total. There are 40 times 100. So a cookie with 23 chips is in the 25th percentile. Okay, as simple as that. All right. So quartile, like I did mention earlier just now, right? Dividing the data into 4, right? So here, just some of the things that you need to know. Okay, the first quartile is 25% of sorted values, from lowest to the highest. And then second quartile is basically 50%, right? Separates the bottom 50 to the sorted values from the top 50%. And Q3 separates the bottom 75% of the sorted values from the top 25%. Okay, so what you need to know is what is interquartile, right? Interquartile basically is Q3 minus Q1. Okay, that means the quartile 3 minus Q1. Semi interquartiles, Q3 minus Q1 divided by 2, right? So there are some of these definitions that you need to know, right? Okay, there are some of the plots that can actually plot your values like minimum, maximum, Q1, Q3, and median, right? Box plot will be very helpful for you to see what is a minimum value, maximum, and then what is a quartile 3, quartile 1, and then even to see outliers as well. Okay, it is a very good plot. You can try, which we will do in one of the tutorials as well. Okay. All right. So this is something that many students been asking me, right? Especially my tutorial groups, and I'm sure the others also. You can always refer to your group project lecturer, which is your tutorial lecturer, okay, to explain about hypothesis. All right. Um, anyway, hypothesis here is very important for your group project as well. But what I'm going to cover here is quite general in terms of understanding what is type 1, type 2 error, what is one tail and two tail test. Okay, it will be useful for you as well. So before doing any kind of statistical test, you first need to understand what is the problem that you want to understand, or what is the problem you want to study, right? And what conclusion you want to make out of that experiment or that study. So you need to do an hypothesis first, right? What you want to test, right? That hypothesis will give will be the one you will be testing to see whether you accept or reject it, right? So just going through some notes here. Hypothesis testing refers to making an assumption called hypothesis about a population parameter, collecting a sample data, and doing a sample statistic. So what you'll do in hypothesis is you make some kind of assumption. Okay, that means you have to, usually this assumption will be something that has been understood or has an history, or people have accepted it in general. Okay, for example, when you are doing a study in a new drug, okay, a new medication that you want to develop, right? For example, a new vaccine. Okay, you have to do the null hypothesis and alternative hypothesis, but the assumption of the null hypothesis will always be this the new drug that is going to be introduced, effect is the same, right? So it does not perform better than the other. All right, so because you want to prove that now this medication performs better or has impact, right? So for that you need the data to be able to say that yes, there is confirmly a difference, right, between the two drugs, right? So this drug is performing better than the other, right? So for these are the assumptions, for example, that you can do, right? So usually the first null hypothesis will always be there is no difference, or you will say it is not significant, or the mean is equal, right? There is no difference between the two things, right? Okay, and then what you'll do after getting the hypothesis, like what you're doing now in your group project is you are designing the questions, right? Hypothesis actually will really help you to design the questions. What questions you want to put in the survey, because hypothesis will roughly tell you what you actually want to find out. Okay, what you want to understand. So for that, your survey, for that you will start thinking, oh, I need this data. So for this, you need to put, of course, when you want the data, you need to put that in the survey question, right? So the next step is now collect the sample data that you wanted through your survey form. Once you get the data, now is the time for you to do the statistics, right? So put in the data into any tool that you want to use, R or SPSS or anything, and then you do the statistical analysis. Okay, and then once you get the analysis in a form of some values, for example, you call it uh, p value, or sometimes you call a significance value. Okay, whatever that we are going to see later on in your class. Using this sample statistic, we evaluate whether to accept or reject our null hypothesis. Okay, so for example, like from just now, if you have heard me saying null hypothesis, this is null. Okay, null hypothesis, this is the symbol, you'll use H0. Alternative hypothesis, HA. Okay, you must have both. All right, it's not you have one and then you don't have the other. Basically, you have to have both, because if you reject your null hypothesis, then you must accept the alternative. For example, under null hypothesis, state the hypothesized value of the parameter before sampling. Okay, before you do the sampling, hypothesize first. Come up with the hypothesis. The assumptions we wish to test or the assumptions we are trying to reject, right? So, for example, we want to try to reject that the medication is equally good with the other one. That means medicine A is equally good with medicine B. You want to reject that, right? Of course, when you want to prove that one medicine is working, you don't want and what to accept that A is as good as B, right? You want to say that there is a difference, right? Whether the difference is positive or negative, that is the second thing, right? You need to do further tests, right? The further statistical analysis that you can do, right? Is A better than B, or B better than A, or A equals to, that is one tail or two tail, that I will explain later. Okay, but the understanding here is the null hypothesis is usually will be there is no difference. Okay, for example, here this is called actually a one tail, right? So what you do, like population mean, the mean in this case is 20, right? That means here accepted the mean is 20, right? There is no difference between Coke and Diet Coke. This is another example. Okay, first example, it can be anything. It's just an example I gave here, 20. It can be anything. All right, for example, what is the mean, how to say, age of a person, an average Malaysian going to work for the first time? Okay, so maybe what is accepted is most of them go to work after they are maybe 23, 24, after they graduate, maybe, right? So you have maybe some kind of assumption that you will do, right? Maybe it's 23. Most of them will go around that age. So you put the mean is 23. Okay. But at the same time, you won't know. Maybe the data that you collected will show that you have to reject your null hypothesis and accept your alternative hypothesis, which is the mean is not equals to 23. Right? Instead, maybe there's something else. Right? But you also can do a one tail test like this, This is two tail. Two tail uses equals to or not equals to, right? One tail you can do like this, right? Whether the mean is more than 23 or mu is lesser than 23. You can do this way as well. Please explore more. As I explained here, you can go and try out and look at what is one tail test and two tail test, okay, for that I'm explaining here, okay. So if you can see, you can write it this way, mu equals to 20, or you can say there is no difference between Coke and Diet Coke, right? So the alternative will be, okay, mu not equals to 20, or you can say mu bigger than 20 or mu lesser than 20. Or for something that is, if this is the null hypothesis, there's no difference between Coke and Diet Coke, then the alternative hypothesis is there is a difference between Coke and Diet Coke. Okay, so this is the two different ways of writing alternative and null hypothesis. Okay, we can discuss this further later on during tutorial, right? and I'll explain there, and at the same time you also can always get back to your tutor or your lecturer for your tutorial groups. Okay, they will be able to explain to you. Okay, so null hypothesis basically represents a theory that has been put forward either because it is believed to be true or because it is used as a basis for an argument. It's what I mentioned just now, right? For example, the age of people going, average Malaysian going to work is at the age of 23. That is maybe an assumption, okay? We don't know, but you can put that as your null hypothesis, right? So there is, for example, we also can write there is no difference between the two drugs on an average, okay? Alternative will be a statement of what a statistical hypothesis test is set up to establish. So that is what you want to prove actually. For example, if you're doing a study, how does social media, involvement in social media affect students' academic performance, right? So your alternative hypothesis is what? Maybe you really want to prove that there is a relationship between the time spent on social media and how they perform in the academic performance. So you will be basically you'll be the happiest person if you could reject the null hypothesis, which says that there is no effect. Correct? So alternative will be usually is the one you want to try to prove. Okay. So in this case, we would write alternative hypothesis, the two drugs have different effects on average, or the new drug is better than the current drug on average. Okay, so reject null hypothesis in favor of alternative, or do not reject. We do not accept alternative or reject alternative hypothesis. Okay, what we are testing is only the null hypothesis. So you say you reject null hypothesis and in favor of accepting the claim in alternative, and you do or you do not reject null hypothesis. If you do not reject your null hypothesis, that means basically you are your test says that there is no evidence or relationship between in what you were testing in the alternative. Okay, that means alternative is not true, right? Or not enough proof to say that alternative hypothesis was true, right? Okay. So now some information on significance level, right? So selecting and interpreting significance level, deciding on a criteria for accepting or rejecting a null hypothesis. Okay, what is a significance level? Right, significance level refers to the percentage of sample mean that is outside certain prescribed limits. Example, testing a hypothesis at 5% level of significance means that we reject the null hypothesis if it falls in the two regions of area 0.025, and we do not reject the null hypothesis if it falls within the region of area 0.95, right? So you are saying here that if you set your significant level 5%, so if your p value is less than 0, if you're using less than 0.05 or 0.025 in this case, then you can reject the null hypothesis. So basically your significance level here determined by you, you as the person who is conducting the experiment or the statistical analysis can set what is your significance level. Okay, if you set 5%, then here you reject if it is less than 0.025. Okay, so if it is 10%, it will be 0.5. Correct? If you choose 10% level of significance, then you reject the null hypothesis if it is less than 0.5. Correct? Sorry, 0. So 5, yeah, okay, 0.05. Sorry, 0.5. All right. Okay, the higher the level of significance, the higher is the probability of rejecting the null. Sorry. Okay, so I stopped here. The higher the level of significance, the higher is the probability of rejecting the null hypothesis when it is true. Okay, this is true. Okay, you just imagine as the significance level here increases, this will increase as well, correct? When you are 5%, then this becomes 0.025. If this is more than that, it will become 0.5, right? If it goes maybe 15% level of significance, this also will increase, right? As this value here increases, right, it is much easier for you to reject the null hypothesis, okay? Because now the p value, right? How you reject the null hypothesis is you will look at the p-value. For example, when you're doing a student t-test, okay, that t-test, when you want to study the significance between two variables, that t-test will produce a p-value, okay? A p-value, you have to check against this value 0.025. Okay, if it is less than 0.025, in this case you can reject the null hypothesis. Okay, but if it is not lesser than 0.025, you cannot reject the null hypothesis. So imagine if this level of significance increases, this also increases, right? If this increases, of course your p-value does not need to be very small in order to reject the null hypothesis, correct? Even if it is your data is not strong enough or significant enough to get a small p-value, even a slightly larger p-value will be still be able to reject the null hypothesis because this value is high, because you set the level of significance as high, right? So I'm not saying that by setting the level of significance very low, it is better than you setting the level of significance high. It doesn't work that way, okay? You set the level of significance depending on the how crucial is your study, or how critical is your study, okay, or how dangerous is your study. For example, there's one example later on which it will show, it will talk about, just say you're talking about medication, right? You want to see whether one medication is working or not, right? Will you give a lower level of significance or higher level of significance? Of course you want to make sure that it's difficult to reject the null hypothesis, because the null hypothesis says the medication is equally good with the existing one. But the other alternative hypothesis says no, the level of performance is different, or maybe you can say it is better than the existing one. You don't want to play with people's life, right? You don't want to like make it easy for your experiment to reject the null hypothesis. So in this kind of cases, of course, you want to make it difficult to reject the null hypothesis. That means only when your data is strong enough, which has enough proof to, we can say power, right? Which has enough power to reject the null hypothesis, then it is okay, right? If not, no point, just for the sake of you want to make sure that this medication can go to the market, you can start selling it. So you just want to prove that yes, we managed to reject the null hypothesis, and yes, it's proven that the medication is working. Of course, you can put a very high level of significance and you claim that, okay, it's working, right? But that's not an ethical way, right? You have to see these kind of things that deals with humans' life and all, or even animals, anyone, right? Anything that affects something, you have to make sure that the level of significance is reasonably tough, right, for them to reject the null hypothesis. It's different maybe for things, right, equipments and all, because you don't deal with human lives and things like that. So the level of significance here really depends on the area of the study that you're doing and how critical it is. That is why this level of significance is defined by the person who's doing the experiment itself. You know how critical is how difficult is it for the you want to make for the experiment to reject the null hypothesis. Okay, so now that is the main thing I wanted to explain about significance level. You must understand why there is a significance level, and you are the one who will set the significance level, and why do some people set it less and why do some people set it high, all right, and how does it affect, right, in terms of rejecting or accepting the null hypothesis. Okay, there are two types of errors here, type 1 and type 2. Okay, simple. Type 1 is null hypothesis is wrongly rejected. Okay, that means it's actually you cannot reject, but your data, the way maybe the computation you have done, or the value, basically significance level, usually is because of that. Okay, the significance level that you have set was too high, that it was so easy to reject your null hypothesis, so you rejected the null hypothesis. All right, so that is called type 1 error. That means there is no difference between the two drugs. For example, type 1 error will occur if we conclude that the two drugs produce different effects when actually there is no difference. They are both the same, but because maybe you set the significance level is very high, you tend to be easily rejecting the null hypothesis. So that what happens, type 1 error, right? These are all human errors, because you don't know. That is why you have to be very careful when you're designing your experiment, right? So type 2 error refers to situation when we accept the null hypothesis when it is actually false. That means actually there is significant difference between two variables. Maybe the two different variables, there is some kind of relationship, and then maybe one is different from the other. But maybe because you make it too tough to reject the null hypothesis because of a too small significant level, so it was so difficult to reject the null hypothesis. So you can't do anything but say that, okay, maybe the two drugs are the same, all right? Or maybe the two groups have the same performance, something like that. You are saying that you conclude that two drugs produce the same effect when actually they are different. That is also not good, right? Okay, so for example, there's an here. Okay, your null hypothesis is that the battery for a heart pacemaker. Do you know what is a heart pacemaker? Okay, the pacemaker that you put in a heart, to help to rhythm your heartbeat, right? So the heart pacemaker has an average battery life of 300 days. Okay, with the alternative hypothesis that the average life is more than 300 days, you are quality control manager for the battery manufacturer. Would you rather make type 1 error or type 2 error? Okay, you think about it. Type 1 error is falsely rejecting the null hypothesis, correct? Type 1 error is HO, null hypothesis, wrongly rejected when actually there is no difference, correct? So you rather make type 1 error or type 2 error? Okay, if you ask me, I rather make type 2 error. Okay, type 2 error is about accepting the null hypothesis when it is actually false. Okay, that means I cannot reject the, if I make the type 2 error, that means I'm accepting that the average life is 300 and I cannot reject the null hypothesis, so I cannot claim that the average life is more than 300. Okay, so I prefer to do that kind of error rather than the first one, because type 1 error, it rejects the alternate the null, which is saying that average life is 300, and accepts the claim that the average life is actually more than 300 days, but actually that's not true. That is type 1 error. So aren't you playing with people's life here? That means just suddenly after 300 days the battery fails, right? Stops, and then your pacemaker stops, right? So we cannot afford to make a type 1 error. It's okay to make a type 2 error. So when you can afford to make type 2 error, what will you do? Type 2 error is what? Type 2 error is we accept the null hypothesis, right? So usually we accept the null hypothesis. You rather make your significance level very, very low, right? So based on your answer to part A, should you use a high or low significance level? Okay, you better use a low significance level, because if you use a high significance level, it is much easier to reject the null hypothesis, and you don't want that. Okay, right? So that is what explained here in these answers. Okay, I hope you understand now what is type 1, type 2 error and how it relates to your p-value, your significance level, and how these things relate to hypothesis, and how hypothesis relates to your survey questions, right? I hope you can start connecting all these, right? These are all connected actually. You need to do step by step, okay? All right, this I actually already explained just now. What is a two-tailed test and one-tailed test? Like I gave you an example. This is an example of two-tailed test. Usually in two-tailed test, we will reject the null hypothesis if the sample mean is significantly higher or lower than hypothesized mean, right? Either one, lower or higher. That means you cannot say that whether it's higher or lower. It's just not equal, right? That is why we use this symbol. The mean, the mu is certain value, or you can say mu is not equals to. So this is one example of two-tail. So it can be higher or lower, and you reject the null hypothesis. Unlike one-tail you can actually reject the null hypothesis if it is you want to test whether it's lower or higher, right? So for example, one-side test is a statistical hypothesis test in which the values for which we can reject the null hypothesis are located entirely in one tail of the probability distribution. So normally what I will do is the mu equals to the equal mu, right? And the alternative will be either you do mu lower than the whatever value you want to give, right? For example, here I'm using mu equals to 100 hours, and alternative is the mu is lesser than 100 hours. So if I manage to reject the null hypothesis, okay, if we reject the null hypothesis, then I can accept that the mu is less than 100 hours. So what this 100 hours refers to is the wholesaler buys light bulb from manufacturer in large lots and decides not to accept a lot unless the mean life is at least 1,000 hours. Okay, so at least 1,000 hours, then only he accepts to buy, right? So he rejects null only if the mean life of sample bulb is significantly below 1,000. Okay, if not, he accepts the alternative and rejects the lot, right? So upper tail test, okay, this lower tail test, okay, I explained the same thing just now. So this is one-sided. One-sided, as I told you, can be either smaller or bigger, right? So lower tail test is you use this, and this is for the upper tail test, right? For example, let's see. A highway safety engineer decides to test the load-bearing capacity of 20-year-old bridge. The minimum load-bearing capacity of the bridge must be at least 10 tons. Okay, must be at least 10 tons. So here equals to 10 tons. The alternative is more than 10 tons. Okay, and uses an upper tail test. So he rejects null only if the mean load bearing capacity of the bridge is significantly higher than 10 tons. That means if your data is powerful enough to show that the load bearing capacity of the bridge is more than 10 tons, then your p value eventually will be less than the significance level set, and you will be able to reject the null hypothesis, and then you accept yes, it is more than 10 tons. Okay, all right, so that's all actually I wanted to discuss. So there's quite a lot of info here, but as usual I would say that once we upload the tutorial, please try, because whatever that I explained here, when you do start doing hands-on, it'll be much easier to understand. And also please discuss with your lecturer or your tutor do your tutorial questions. Sorry, if you have any questions about your tutorial besides what I'm going to upload for the Wednesday tutorial, okay? Other than that, this is very important. This things that I shared today is important for your group project as well, okay? Because you'll be using hypothesis, you will be using significance level, right? And then you will make conclusion out of that. So I hope this hypothesis part which I included here will be beneficial, and as you do your group project, go back to your lecturer of your for your project and ask how you can do this and implement it for your group project. Okay, so this is a gradual process. Okay, it's a learning process, so it's okay if you totally don't understand fully now, but please bear in mind this is something that you have to apply in your group project. Okay, start doing your hypothesis for your group project and discuss it with your lecturer. Okay, so thank you very much. I will see you later during your tutorial. Okay, goodbye.